Welcome to Application Development Lifecycle. After watching this video, you will be able to list the steps in the application development lifecycle, describe the different phases of the application development lifecycle, and recognize the importance of writing application codes in multiple files. Imagine this. A customer requests you to build an application to help their employees track their daily tasks. Now, consider a scenario where a customer wants you to build a web app to manage hotel reservations, from creation to customer checkout. In either scenario, can you start building the application when the customer makes a request? Not really. You will need to perform certain activities like analyzing requirements, planning, and coding before the application is ready for users. Regardless of the application type, every application will go through different phases, called the application development lifecycle. You can divide the application development lifecycle into 7 phases: requirement gathering, analysis, design, code and test, user and system test, production, and maintenance. Let's look at each of the application development phases in detail. Requirement gathering is the first phase in the application development process. In the requirement gathering phase, you will capture the requirements across all aspects of the application, including user requirements, business requirements, and technical requirements. Let's consider the hotel reservation app. For this app, a user requirement may be that users must be able to view the different rooms and amenities available. Determining the right charge for different rooms and amenities may be a business requirement. A technical requirement might be that the app must run on all browsers and mobile devices. The goal should be to capture as many requirements as possible, even if it seems redundant or trivial. You must also identify any constraints of design and viability of the business model. For example, for the hotel reservation app, one constraint is that the server needs to keep the status of room availability updated at all times, which has an associated cost. Therefore, to keep the business viable, a minor convenience fee is added to the final payment. After gathering the requirements and constraints, you must analyze each to create a possible solution for the application's design. During analysis and design, there might be multiple rounds of verification and revision to create a model solution that meets all the specified requirements. Across the analysis and design phases of application development, you must maintain proper documentation with records of all updates in the design. The documentation should be clear and concise as used during the code and test phase. The final proposed design and the specified requirements are passed on to the code and test phase. During the code and test phase, the team uses the programming requirements specified in the design documentation to code, test, revise, and test the application programs until the code meets all documented requirements. Let's review the testing phase. The tests you conduct for the unit code is called unit testing. Conduct the unit testing at the programming level to ensure you meet all required specifications. After the unit testing, you can generate an acceptable application version. The new version of the application is then run through a series of user and system level tests. The user tests verify the functionality from a user's point of view. In addition, you will need to execute several system level tests, including integration and performance testing. Integration tests verify that all involved programs continue functioning as expected after integration. Integration testing also verifies that the application functions within a larger framework. Performance testing helps evaluate the speed, scalability, and stability of the application based on varying workloads. After testing, you can generate a new application version and send it to production. Once in production, end users can access and use it. You must ensure that the application functions accurately and is available to users. When the application is in the production phase, it must remain in a steady state. In a steady state, you should not make any changes to the application. However, this is not always possible. For example, you might need to make changes to the application in case of an error. These changes are tightly controlled and heavily tested before being implemented into production. The last phase in the application development lifecycle is maintenance. The application might need an upgrade, or you might need to add new features. In this case, the new features must go through all previous phases before being integrated into the application version deployed in production. Let's briefly review why maintaining multiple files for coding different functionalities is a best practice. Every app usually has multiple functionalities, and the requirements for each functionality might vary. The best practice is to code each functionality in separate files. You can then create a central program, which runs the application and calls the individual files to perform specific functions. This approach to organizing code makes code maintenance efficient and easy. Having multiple files also helps when you need to add new functionality to an existing application. When you write the code for new functionality in a separate file, only the file will go through the entire design and verification process before being integrated into the running application. In this video, you learn that the application development lifecycle has 7 phases, including requirement gathering, where you collect user, business, and technical requirements for the app; analysis, where you analyze the requirements; design, where you design the complete solution; code and test, where you build and test the different components of the app; user and system test, where users test the app for usability and you perform system integration testing and performance testing; production, where the application is available to all end users; maintenance, where you upgrade or fix any user or system issues. For efficient coding, always use a central program to call the individual files and functions for performing different actions. Welcome to Introduction to Web Applications and APIs. After watching this video, you will be able to describe web applications or web apps, describe an application programming interface or API, compare and contrast web apps and APIs. Let's start by defining a web app. A web app is a program stored on a remote server and delivered over the internet. A user interacts with the app using a browser. Web services like e-commerce sites, webmail, and so on are all web apps. While some apps may depend on the kind of browser being used, most web apps work on all modern web browsers. A web app requires 3 components to process a client request: a web server to manage raised requests, an app server to execute the requested task, and a database to store the information needed to complete the task. When programming web apps, you will write code for the user end or the front end using JavaScript, HTML, or CSS. You will also code for the server end or back end using Python, Java, or Ruby. There are several advantages to using web apps over apps that strictly run locally on a user system. The advantages include developers can make the same version of the app available to multiple users at the same time. Users have the flexibility of using the app from their platform of choice, such as desktop, laptop, or mobile device. Users can access the app through the browser of their choice. Users do not need to install the app on their local systems. An API is a software component that enables 2 apps that are not connected with each other to communicate. APIs help create more flexibility for programmers and enable them to request data from otherwise closed-off apps. As a result, APIs have standardized rules and functions that determine what data can be taken or modified within an app and how that process occurs. For example, the apps on your phone require you to grant permission to different features of your phone, like location, camera, audio, and recorder. An example of an app that uses an API is a weather app. Your weather app does not generate weather data itself. Instead, it simply requests information from a weather API. The API connects the software that gathers and stores weather data with the app on your mobile device. The device, in turn, provides you with a detailed forecast for the next day. There are several architectures software developers follow to create an API, but the most popular is Representational State Transfer, or REST, or Simple Object Access Protocol, or SOAP. These architectures will be discussed in another video. An API can be beneficial for many reasons, including it improves connectivity between apps. It supports traditional create, read, update, delete, or CRUD actions. It works with HTTP verbs, including put, post, delete, and get. It is based on HTTP, making it customizable. API is a more generic term given to all forms of apps that create a link between any 2 parts of a system. Web apps are a form of API that communicate between the front end and the back end. To clarify the distinction between web apps and APIs, let's consider the example of an e-commerce shopping service. When you access the e-commerce shopping service from a browser, the browser acts as the API that connects you to the web apps. When you select a product, The web app checks the availability of the product and, if available, displays its price. If you try to access the e-commerce shopping service using a mobile device, the app on your device acts as the API that connects to the e-commerce shopping service. The nature of all web apps is to share data with other apps. Essentially, all web apps may be considered APIs. However, API is a generic term and includes both online or web-based and offline apps. To summarize, all web apps are APIs, but not all APIs are web apps. In this video, you learn that web apps are programs stored on a remote server and delivered over the internet through a browser. You can run web apps on different platforms and browsers without having to install new software. An application programming interface, or API, is a software component that enables two unconnected apps to communicate. Web apps are APIs, but not all APIs are web apps. Both share data between apps, but not all APIs require networks like web apps do. Hello everyone, and welcome to the demo on the Cloud IDE, or Integrated Development Environment, provided by the IBM Skills Network team. Cloud IDE is a programming environment for learning, which you can use for writing, running, debugging, and executing code directly in a browser, without the need to install or configure any software or tools on your personal device. In this demo, you will learn to navigate the different components of the Cloud IDE, install the Python packages or libraries, write code, execute code. When you open the Cloud IDE, two main panes will be displayed. The left pane is referred to as the instructional pane. It displays the instructions that you need to follow to finish the project. The pane on the right displays a programming interface where you can write and execute your code. Please note that the right pane is similar to the VS Code interface, which is a popular IDE for managing code. You can resize the instructional and code panes. For example, you can reduce the size of the instructional pane by dragging it from its margin towards the left, or you can increase the size by dragging the instructional pane towards the right. You also have the option to modify the fonts and font size based on your preference. If there are multiple pages in the instructional pane, you will see the Next and Previous buttons. These buttons enable you to navigate between the pages. You can also preview an instructional page. Notice the Table of Contents button on the top left corner of the instructional pane. Use this button to navigate through different sections of the instructions. Next, let's look at an AI-enabled chatbot available on the Cloud IDE. The IBM Skills Network team provides you with an AI-enabled teaching assistant chatbot called Ty, which provides you with help using the lab environment for coding assignments. The icon for Ty is available on the left side of the instructional pane. To access the chatbot, simply click the icon. Let's try asking a question like, "Please provide me with simple Python code." As you can see, the code is displayed. You can either copy or execute the code. Next, let's look at the programming interface of the IDE. The programming interface has several components. However, the two tabs that you will use frequently include the Editor tab, where you write the code, and the Terminal tab, where you execute the code. In the programming pane, there is also a Skills Network toolbox, which enables you to work with various database management environments, big data tools, cloud tools, embedded AI libraries, and launch applications that you build. Before you begin writing the code, you will need to install the required Python libraries or packages in this cloud-based environment. You will need to perform this task in the Terminal tab. To open a new terminal, click the Terminal menu, then click New Terminal. For the purpose of the demo, let's copy the code block from the instruction pane and paste it on the terminal. Then, press Enter to execute the command. Notice that the NumPy library has been successfully installed. You can now import this library into your code. Let's now create a basic Python program. In the Programming pane, click File, then select New File. The new file opens in the Editor tab. It is a best practice to save the file before starting to add code. Since we are writing a Python code, save the file with a .py extension. From the File menu, click Save or Ctrl+S. When prompted, provide the file name. For this example, let's save the file as hello.py. The next step is to add the code. You can manually type the code in the Editor tab or copy and paste the code from the instruction pane, if available, to your file. For the purposes of this demo, let's copy the code from the instruction pane and paste it in the file. Don't forget to save the file. It's time to execute the code. Let's navigate back to the Terminal tab. Make sure that you are in the folder where the program file is stored. You can execute the file by typing python3 followed by the file name. For this example, that's python3 hello.py. Notice that the output is displayed without any errors. This brings us to the end of the demonstration on the Cloud IDE. To summarize, Cloud IDE is a programming environment similar to VS Code, provided by IBM Skills Network for the purposes of learning and developing hands-on skills. The Cloud IDE has two panes, Instructional and Programming. You can use the Table of Contents button on the Instructional pane to navigate between instructional pages. The Programming pane provides the Editor tab to write code and Terminal tab to execute code. You need to install the required libraries through the terminal. At any point during the labs, you can copy the code blocks from the instruction pane and paste it in the Editor or Terminal tabs. Welcome to Python Style Guide and Coding Practices. After watching this video, you'll be able to describe the importance of writing readable code, list the Python coding conventions, explain static code analysis. When you write code, you need to ensure the team can read and understand it easily. This task requires some coding standards and conventions. Python.org has released a document called Python Enhancement Proposal 8, or PEP 8, that provides conventions and guidelines to make your Python code readable and consistently formatted. Let's start with the key guidelines for improving the readability of the code. PEP 8 recommends the use of spaces instead of tabs for indentation. Wondering why? Different text editors and integrated development environments, or IDEs, interpret the number of spaces in a tab differently. For example, one editor might interpret a tab as 3 spaces, while another might interpret it as 4. Using a tab for indentation can lead to non-uniformity in code, resulting in formatting errors. For example, observe the spacing difference when tab is pressed for statement 1 for the if condition under editor 1 when compared with the space before statement 1 for the if condition under editor 2. To avoid such errors, you should use a consistent number of spaces when indenting your code. For uniformity, the guideline is to use 4 spaces for every indentation level in a code. 4 spaces for an indentation are sufficient for appropriate readability. Please note that the 4 dots have been added before statement 1 and statement 2 to depict 4 spaces. PEP 8 also recommends using blank lines to separate functions and classes in the code. Notice that in the left block, which does not follow PEP 8 guidelines, there is no space between where function 1 ends and class user class, capital U and capital C, no space. However, the right side shows the correct representation with a space before the class definition. The blank lines help establish the beginning and end of different parts of the code. To improve code readability, use spaces around operators and after commas. Using spaces will make the commands look spacious and discrete, improving command readability. Let's look at some examples. When you write A equals B plus C without any spaces, it can be confusing. However, when you add the spaces, for example, A space equals space B space plus space C, readability improves. Next, let's look at some coding conventions to maintain consistency and manageability. A key coding convention is to create separate functions for functionalities with larger blocks of code. You can then call the functions from the main program. For example, in the code, The if-else syntax does not have a function and will need to be written every time you need the functionality. However, if you notice function_1 written as def function_1 with two parameters a and b, it can be called easily. For example, c equals function1 a, comma b. This increases the execution speed of the code and supports the reuse of the code block in a much more convenient way. Another coding convention is to name the functions and files using lowercase with underscores. Wondering why? Python uses the naming convention and has many built-in libraries and predefined functions that use the common naming conventions. Therefore, using a lowercase function name, preferably with underscores, is advisable to make the functions unique. For example, instead of writing function name as comp surface with capital S, radiation with capital R, write comp_surface_radiation. An exception to the rule is the naming criteria for Python packages, where underscores are generally discouraged. For example, instead of writing my_package, write myPackage. Naming the classes using camel case is also a coding convention. Camel case, or the cap word case, is a naming convention for classes that is well accepted in the coding community. Camel case also helps distinguish between classes and functions in the code. For example, instead of writing class lamb_squirrel_cage, the best practice is to name the class as lamb squirrel cage with the initial L, S, and C in capital letters. Use the coding convention of capitalizing all words and separating them with underscores for consistency. The name usually indicates the constant's purpose. For example, max file upload size in capital letters. We discussed the coding convention and guidelines. Software developers commonly use static code analysis to manage compliance with these style guidelines. Static code analysis is a method to evaluate code against a predefined style and standard without executing the code. Static analysis helps find issues such as programming errors, coding standard violations, undefined values, syntax violations, and security vulnerabilities. You can use the PyLint library to check the compliance of your Python code with PEP 8 guidelines. In this video, you learn that writing consistent code helps all team members read and understand the code easily. The PEP 8 guidelines for better code readability include the following: 4 spaces for indentation, use blank lines to separate functions and classes, and use spaces around operators and after commas. Some coding conventions for code consistency and manageability include: add larger blocks of code inside functions, name functions and files using lowercase with underscores, name classes using camel case, and name constants in all capital letters with underscores separating words. Use static code analysis method to evaluate your code against a predefined style and standard without executing the code. Welcome to Unit Testing. After watching this video, you will be able to define unit testing, explain the unit test process, build and execute unit tests, and review the output of a unit test. Unit testing is a method to validate if units of code are operating as designed. A unit is a smaller, testable part of an application. Here is an example of a unit, which has 2 functions, square and doubler, in the mymodule.py file. The square function is written as def square number, return number raised to the power of 2. Similarly, the code for the doubler function is written as def doubler number, return number multiplied by 2. To develop unit tests, you will use the unit test library, which is an installed Python module providing a framework containing test functionality. Let's briefly review the end-to-end testing process from unit testing through publishing to the production codebase. During code development, you will test each unit. The test is performed in 2 phases. In the first phase, you will test the unit on your local system. If the test fails, you will determine the reason for the failure and fix the issue. Then, you will again test the unit. After the unit test passes, you will need to test the unit in a server environment, such as the Continuous Integration Continuous Delivery, or CI/CD, test server. If the unit fails the server test, you will receive the failure details. You will need to determine and fix the issue. Once the unit passes the server test, the unit is integrated into the final code base. After an overview to the unit test process, let's review some test functions to understand how to build unit tests. Notice the code for the unit and the unit test. Observe that the name of the unit file is mymodule.py. The unit test file has the word test appended or prepended. This is a good naming convention as it helps to clearly differentiate the unit file from the unit test file. Let's look at the steps to create a unit test file. The first step is to import the unit test Python library. Type import unit test. Next, import the functions to test. For example, to import the square and doubler from the mymodule unit to unit test, type from mymodule import square, doubler. Then, build the unit testing class to call the unit test from a single class object. For example, to create a class named test_my_module, enter class test with uppercase T in the first occurrence, my with uppercase M, module with capital M, unitest dot test case with T and C in uppercase. Notice how the class name has test prefixed to the unit name in the example. It is a good naming convention to prefix test to the class name to help distinguish between the unit class and the unit test class. Next, make the class inherit the test case class of the unit test library. For example, test case is the test case class of the unit test library. Inheriting the class allows you to leverage the existing methods in the test case class. Then, create functions in the unit testing class corresponding to each function that needs to be tested. For example, in the test_my_module class, two functions, test square and test doubler, correspond to the square and doubler functions in the mymodule unit. Note: make sure that the functions are prepended with the test in the unit test module, because only functions that start with test are run. Finally, you can create test cases. When creating the test cases, add one or more assertion methods to ensure that the unit test condition is met. One assertion function is assert equal. Notice that the method has been added to the test case class in the code. The assert equal function compares two values or entities and determines if they are equal. The method is used to check if functions are returning the correct values. One of the parameters that the assert equal function takes is the actual value. For the actual value, you will call the function that you want to test. The second parameter is the expected value, where you will add what the function is expected to return. In the example, the first test is for the square function using the number 2, which should return a value 4 if the function executes correctly. As part of the test, first, the function is evaluated. Then, the two values are compared to see if they are equal. Depending on the output of the comparison, the test passes or fails. After running the test file, an output is generated. The output displays the test results along with some additional details. For example, if the output displays that 2 tests were run in 0 seconds, OK indicates that the test passed and the 2 functions were implemented correctly. But what happens if the function was not implemented correctly? Consider the square function where you wrote the code to calculate the cube of a number instead of square. The function fails and an output is generated. Let's review the sample output of a failed unit test. The output clearly displays that the unit test failed. For example, the output states failed test square main test my module with capital T and M and no spaces. You can also view the function where the unit test failed. For example, in the test square function, the assertion self.assert equal square of 2, 4 failed. An assertion error occurred because 8 is not equal to 4. The detailed output enables you to correct a mistake before the actual deployment of your solution. In this video, you learn that unit testing is a method to validate if units of code are operating as designed. During code development, each unit is tested. The unit is tested in 2 phases. Once the unit passes the server test, the unit is merged into the final code base. Make sure that the test files are pre-appended or appended with the word test to clearly differentiate them from the module file. You can use different test functions to build unit tests. Assert equal function is a commonly used assertion method to compare two values. You can review the unit test output and determine if the test passed or failed. Welcome to packaging. After watching this video, you will be able to differentiate between Python module, package, and library, create a Python package, verify a Python package, and use a Python package. Modules, packages, and libraries are frequently used terms in Python. Let's look at each of the terms in detail. A Python module is a .py file containing Python definitions, statements, functions, and classes. You can import a module to other scripts and notebooks. For example, consider a module named module.py that has two functions. The first function is def square number return number ***2, which squares the input and returns the result as an output. The second function is def doubler number return number **2, which doubles the input and returns the result as an output. If the function is in the same directory, you can import it and use the functions in that module. Let's consider using the square function with print command, 4*2 square 4. The output is displayed as 4*2 equals 16. Similarly, for the print doubler function with value 4, the output is 2*4 equals 8. A package is a collection of Python modules into a directory with an init.py file, which distinguishes it from just a directory of Python scripts. The example shows the package myProject in parent directory with two modules, module1.py and module2.py. It also contains init.py file. When you import a module or a package, the corresponding object created by Python is always of type module. Note that the distinction between module and package is only at the file system level. A library is a collection of packages, or it can be a single package. Examples include NumPy, PyTorch, and Pandas. Note that the terms package and library are often used interchangeably. Therefore, NumPy, PyTorch, and Pandas are also referred to as packages. Let's look at the steps to create a Python package. Consider there are two modules. Module1.py has two functions, square and doubler. Module2.py has one function, mean. To make myProject folder into a package, you must have init.py as a file in the myProject folder. The contents of the init.py file must be from .import module1 and from .import module2. Typical steps to create a package include: first, create a folder with the package name. Then, create an empty init.py file. Create the required modules. Finally, in the init.py file, add code to reference the modules needed in the package. After creating the package, you need to verify the package. To verify the package, first, open a bash terminal. Make sure the directory is the same as the folder where your package is located. Open the Python interpreter by running the command python in the shell. Using the Python prompt, type import followed by project name, for example, import myProject. If the command runs without errors, it is an indication that the package is successfully loaded. The general structure for testing your package is the package name, .module name, .function name, followed by the parameters without the curly brackets, but keeping the round brackets. For example, using myProject, myProject.basic.square, the function will return the value 4. After creating the package, you can use it in the other scripts if the package folder is in the same directory. In this case, you have the file test.py in the parent directory. You can import the functions in the package. For example, using the Python code from myProject.module1, we import the square and doubler functions. From myProject.module2, we import the mean function. Then, we print the result of square 4. Next, we print the result of doubler 4. Finally, we use the mean function with the values 2, 1, and 3. You can then run the functions and check if you get the correct results. In this video, you learn that a Python module is a .py file containing Python definitions, statements, functions, and classes. A package is a collection of Python modules into a directory with an init.py file. A library is a collection of packages, or it can be a single package. To create a package, create a folder with the package name, create an empty init.py file, create the required modules. In the init.py file, add code to reference the modules needed in the package. You can verify the package via the bash terminal. After creating the package, you can use it on other scripts if the package folder is in the same directory. Welcome to Python Libraries and Frameworks for Application Development. After watching this video, you will be able to describe the Python libraries for app development, define a framework for app development, identify the benefits of using a framework for app development, compare frameworks and libraries. Python libraries are like toolkits. Each library has specific tools to simplify and expedite certain programming tasks. Libraries like NumPy facilitate advanced mathematical calculations. Pandas offer data manipulation and analysis capabilities. Matplotlib simplifies data visualization. These libraries save developers significant time and effort in creating these functions. For web application development, some Python libraries are essential. The requests library simplifies the process of sending HTTP requests. Beautiful Soup makes it easy to scrape information from web pages for iterating, searching, and modifying the parse tree. SQL Alchemy is an SQL toolkit and object relational mapping, or ORM tool. It is a system that gives application developers the full power and flexibility of SQL. PyTest is a testing framework that allows users to create small, simple tests easily, yet scales to support complex functional testing for applications and libraries. Frameworks are predefined structures for application development. In addition, frameworks provide a set of guidelines for application development. Frameworks facilitate good coding practices by offering a well-defined structure for writing and organizing code and enabling the reuse of code libraries for added features. Some examples of frameworks include Django, Flask, and Web2Py. There are several benefits of using a framework for app development. One of the benefits of using a framework is that it eases the development process with the pre-written code libraries, modules, and developer guidelines. With pre-built debugging tools, web frameworks simplify the process of debugging web applications for the developers. Another benefit of using frameworks is that developers can add more functionality using less code. How? A framework is equipped with several pre-built libraries and modules, which a developer can leverage when creating their code. A developer does not need to create all required functionalities from scratch. Using frameworks improves database management efficiency. The frameworks come with built-in database integration tools, which help seamless integration of database endpoints for transferring data. With security being a key concern for application users, a benefit of using frameworks is that developers can leverage the built-in security features and guidelines to enforce security. Let's briefly look at how frameworks and libraries differ from each other. The framework contains the basic flow and the architecture of an application, which enables you to build the complete application. A Python library is a set of packages that perform only specific functionality. In this video, you learn that Python libraries are like toolkits. Each library has specific tools to simplify and expedite certain programming tasks. Frameworks are predefined structures for application development. Using frameworks provides various benefits, including easing the development process, simplifying the debugging process, enabling more functionality with less code, improving database management efficiency, and enforcing security. Framework enables you to build the complete application, while libraries aid with specific functionality.
Welcome to Introduction to Flask. After watching this video, you will be able to Define the Flask web framework and describe its main features. Explain how to install Flask on your machines. Describe main dependencies of Flask, and explain the main differences between Flask and another Python web framework called Django. Flask is a microframework that can create web applications. It is not opinionated like some other larger frameworks and does not bind the user to a specific set of tools. One of the complex dependencies of Flask is Python. You will run Flask 2.2.2, which requires a minimum Python version of 3.7. In 2004, Armin Ronischer created the framework as an April Fool's joke. It quickly gained popularity for its ease of use and extensibility. Flask provides minimal dependencies you might need to create a web application. However, it is extensible, and many community extensions add additional features to Flask. The main features of Flask include the following. Flask has a web server that runs applications in development mode. Flask also comes with a debugger to help debug applications. The debugger shows interactive traceback and stack trace in the browser. Flask uses standard Python logging for application logs, and you can use the same logger to log custom messages about your application. Flask provides a way to test different parts of your application. The testing feature enables developers to follow a test-driven approach. And you can use frameworks like PyTest and Coverage to ensure your code works as desired. Finally, developers can access the request and response objects to pull arguments and customize responses. Now, additional features of Flask are the following. The framework supports static assets like CSS files, JavaScript files, and images. Flask provides tags to load static files in the templates. You can also develop dynamic pages using Jinja templating framework, and these dynamic pages can display information that may change for each request or may check if the user is logged in. Flask provides routing and supports dynamic URLs that are extremely useful for RESTful services. You can create routes for different HTTP methods and provide redirection in your application. You can write global error handlers in Flask that work on the application level. And finally, it supports user session management. Some of the popular community extensions that can be added to your application are the following. Flask SQL Alchemy adds support for ORM called SQL Alchemy to Flask, giving developers a way to work with database objects in Python. Flask Mail provides the ability to set up an SMTP mail server. Flask Admin lets you add admin interfaces to Flask applications easily. And Flask Uploads allow you to add customized file uploading to your application. Here are some other extensions. Flask Cores allows your application to handle cross-origin resource sharing, making cross-origin JavaScript requests possible. Flask Migrate adds database migrations to SQL Alchemy ORM. Flask User adds user authentication, authorization, and other user management activities. Marshmallow adds extensive object serialization and deserialization support to your code. Finally, Celery is a powerful task queue that can be used for simple background tasks and complex multi-storage programs and schedules. Flask is available on the Python package manager called pip, and pip is available in the lab environment. However, if installing on your machines, it is recommended that you first create a virtual environment using the venv or pipenv module. You can install Flask version 2.2.2. Now, it is recommended to pin the version number of the dependencies in your application. This ensures that the application can be reproduced from scratch in different environments like development, staging, and production. It also ensures new issues and bugs are not introduced by mistake when packages are updated automatically without a version number. Flask comes with some built-in dependencies that enable the various features. WorkZug implements WSGI, or the Web Server Gateway Interface. This is the standard Python interface between applications and servers. Jinja is a template language that renders the pages in your application. Markup Safe comes with Jinja. It escapes untrusted input when rendering templates to avoid injection attacks. It's Dangerous is used to sign data securely. This helps determine if data has been tampered with and is used to protect Flask's session cookie. And finally, Click is a framework for writing command line applications. It provides the Flask command and allows adding custom management commands. To see the built-in dependencies, you can use the pip freeze command in the virtual environment, and you can see that all the inbuilt packages are installed by default. Now, another Python developer framework is Django. Here are some key differences between Flask and Django. Flask aims to be a very light framework. Django, on the other hand, is a full-stack framework. As a result, Flask only provides the basic dependencies needed to create a web application. However, the developer can choose other extensions that provide additional features. Django, on the other hand, includes everything you need to create a full-stack application. Also, Flask is very flexible. You can add and remove pieces in a plug-and-play manner. On the other hand, Django is opinionated and makes most decisions for the developer so they can focus on the application's logic. In this video, you learned that Flask is a micro-framework that ships with minimal dependencies. To build websites, Flask has features like debugging servers, routing, templates, and error handling. Flask can be extended by using community extensions. Flask can be installed as a Python package. And Django is a full-stack framework compared to Flask. Welcome to Basic Application and Routes. After watching this video, you will be able to create and run a Flask application with basic routes in place. Explain how to return a JSON response from the server to clients, and describe various configuration options available in Flask. Before you create your first Flask application, ensure that you have installed Flask. Next, create a Python file that will be your server, and let's name this file app.py. Now let's write the code in this file. First, import the capital FF Flask class from the small f Flask module. Next, instantiate an object on the Flask class as your app. The constructor takes a single argument of class scaffold. You set the name in the scaffold by passing the name of the app module in the built-in name variable. This name is used to find the resources on the file system and by extensions to provide debugging information. Okay. Now that you have defined your server, let's add the first route. You want to return a message to the client when you call your server without adding a path. So you need to use the @app decorator to define a route. And the decorator takes the path as an argument. Finally, you can return text or HTML from the method. Let's look at the code. The @app decorator is defined on the hello world method. It takes in the argument of slash and returns the HTML message, my first Flask application in action, in bold. The next step is to run your application. The first step is to create a few system environment variables. Now, you need a variable Flask app containing the name of the main server file. In addition, you need a Flask env variable that will define the development or production environment. This variable will be deprecated in Flask 2.3. As you can see, you have defined the Flask app environment variable as the file name that contains the central server and Flask env of development. Finally, to run the application, pass the run argument to the Flask framework by executing Flask run. The Flask application is run by default on port 5000. You can browse to HTTP localhost 5000 to see your message. Let's also use the browser development tools to see what information comes back from your server. The requested URL is HTTP localhost 5000. The request method is HTTP GET. The response has a status of 200, which indicates a successful response. The content type in the response header is text/HTML, and the server is WorkZug running with a Python version of 3.6.15. Congratulations on running your first Flask application. Now, you need to set environment variables for each application before running your application. You can pass configuration to the Flask command by using "-app" to identify the Python file to run, and add "-debug" to enable the development mode. The debug flag also enables automatic restarts when source files are changed, and is useful when you develop applications and want to see your changes instantaneously. In your case, the app is stored in a file called app.py. So you could have skipped this argument, as Flask will look for app.py in the current directory by default. Now, the output should look something like this. The screen shows the Flask application running in development mode as before. There are multiple ways to return JSON from your Flask application. One method is to return a serializable object like a dictionary or a list. In the given code, you return a Python dictionary, and Flask will use the Python JSON module to return JSON to the client. Let's test if this works using the curl command. You will make a GET request to localhost 5000, and you can see a response status of 200 OK. Instead of HTML, you can also see the application/JSON content type. Finally, you can see the JSON that is returned. But note, if you return a more complex object like a class, ensure that it can be serialized. The second way is to use the JSONify method provided by Flask. This method takes in key value pairs at input and returns the appropriate JSON. Let's look at an example. You first import JSONify from Flask, and next you pass in key value pairs to JSONify. You should get the same result as before in the browser, and the developer tools should look the same with a status code of 200 OK and return the content type of application/JSON. Now, you looked at two configurations with Flask env and Flask app variables. Flask provides various other configuration options that you might use in your application. env indicates the environment, production, or development the app is running in. Debug enables the debug mode. Testing enables the testing mode. Secret key used to sign the session cookie. Session cookie name is the name of the session cookie. Server name binds the host and port. And JSONify defaults to application/JSON. In addition, there are other ways you can provide configuration options to Flask. Flask provides a config object, and you can insert configuration options into this object. If you already have environment variables, you can load them into the config object. Finally, you can keep the configuration options in a separate JSON file and load them using the FromFile method provided by the config object. Now, as your app grows, you should create a directory structure instead of using a single Python file, and there are many ways to structure your application. Here is one example. Store the main source code in its module directory and store all configurations in its file. Store all static assets like image, JavaScript, and CSS files separately. Store all dynamic content in a template directory. And place all test files in a test directory and have a virtual environment that can be activated to install the right version of dependencies. In this video, you learned that you can create a server by instantiating the Flask class. Use the @app decorator to create URL handlers. Return string messages or use the JSONify method to return JSON objects. And you can set application configuration from environment variables, Python files, and app.config object directly. Welcome to Request and Response Objects. After watching this video, you will be able to explain the Flask request object and explain the Flask response object. Let's learn how to customize routes in Flask. You define the path using the route decorator, and the add_app.route decorator defaults to the get method. Clients can only send get requests to the specified path. Now, you can pass in a second argument of methods to control what HTTP methods the path responds to. For example, look at the following two methods that are the same. The get method is implicit in this code, while this code explicitly specifies the get method. Here's another example. The /health URL will respond to get and post requests. If the request is get, the code outputs the status of OK and the method of get. If the request is post, the code outputs the status of OK and the method of post. This is the output from the get curl command, while this is the output from the post curl command. All HTTP calls to Flask contain the request object created from the Flask.request class. When a client requests a resource from the Flask server, it is handled by the add_app.route decorator. You can examine and explore the request object in the same method. Now, the following information is available in the request object: the address of the server in the form of a tuple host port, the header sent with the request, and the URL that is the resource asked by the request. Access route that lists all the IP addresses for requests that are forwarded multiple times. Full path that represents the complete path of the request, including any query string. Is secure is true if a client makes a request using HTTPS or WSS protocol. Is JSON is true if the request contains JSON data. And the cookies dictionary contains any cookies sent with the request. In addition, you can access the following data from the header. Cache control holds information on how to cache in browsers. Accept informs the browser what kind of content type is understood by the client. Accept encoding indicates the code content. User agent identifies the client, application, operating system, or version. Accept language requests for a specific language and locale. And host specifies the host and port number of the requested server. Now, you can replace the request object with a custom request object, which is usually optional as the Flask request class attributes and methods are enough. Let's now look at some actual values printed on the server when a client makes a request. In this case, the client is the curl command from the terminal. The request server is 127.0.0.1 or localhost at port 5000. You next print out some headers. The host is the full path of localhost :5000. The user agent is curl version 7.79.1. And the client has requested the content type of application/JSON. Okay, let's look at some more attributes from the request object. The URL requested is http://localhost:5000. The access route list contains the single value of 127.0.0.1. The full path for the request is the home path indicated by a single /. Is JSON is false, as we are not sending any data with the GET request. Is secure is false, as the URL is HTTP and not HTTPS. And the length of the cookies dictionary is 0. There are multiple ways to get information from the request object. Use the get data to access data from the post request as bytes. You are then responsible for parsing this data. You can also use the getJSON method to get data parsed as JSON from the post request. Now, Flask also provides more focused methods to get exact information from the request, so you don't have to parse the data into a specific type. Args will give you query parameters as a dictionary. JSON will parse the data into a dictionary. Files will provide your user-uploaded files. Form contains all values posted in a form submission. And values combines the args data with the form data. Now that you know what the request object looks like and the methods to get data from the request parameters and body, let's see how to extract specific values from this data. The return types for the methods you have seen so far are either a multi-dict, immutable multi-dict, or a combined multi-dict. All these data structures behave like a Python dictionary, and you can use indexing or the get method to extract values. For the given URL, you would like to extract the query parameters of capstone and rating. First, you import Flask and the request modules in your method. You extract the value for the course argument by using indexing. Then, you extract the value for the rating argument by using the get method. The get method returns a value of none if the argument is not present, whereas the indexing method returns an error and stops the server with a 400 bad request. The message shows the request in the browser with a course of capstone and a rating of 10. Flask will provide a response object just like it provides a request object, and you can use the response object to send custom attributes and headers back to the client. Some common response attributes include the following. Status code indicates the success or failure of the request. The headers give more information about the response. Content type shows the media type of the requested resource. Content length is the size of the response message body. Content encoding indicates any encoding applied to the response so the client knows how to decode the data. MIME type sets the media type of the response, and expires contains the date or time after which the response is considered expired. Here are some standard methods on response objects. setCookie sets a browser cookie on the client, and deleteCookie deletes a cookie on the client. Let's now learn how Flask works with the response object using the different methods. A response object with the status code of 200 and a MIME type of HTML is automatically created for you when you return data from the @route method. JSONify also creates a response object automatically. You can use makeResponse to create a custom response. Flask provides a special redirect method to return a 302 status code and redirect the client to another URL. And finally, Flask provides an abort method to return a response with an error condition. In this video, you learned that Flask provides a request and a response object for each client call. You can get additional information from the Flask request, like headers. You can parse the request object to get query parameters, body, and other arguments. And you can set status on response objects before sending a response back to the client. Welcome to Dynamic Routes. After watching this video, you will be able to describe how to call an external API in Flask, and describe how to pass parameters to routes in Flask. Let's look at an example of how you might call an external API in Flask. Now, the easiest way is to use the Python requests library. You can return the JSON from the external API to your client. However, you can also process the results before sending them back to your client. Here is an example. First, you import Flask and request modules. The code here assumes you have already installed the requests library. You can define your route next. Use the requests library to request the Open Library API and search for information for the author, Michael Crichton. Now, store the response in a variable called res. Then, check if the response status code from the Open Library API is 200. If the response is 200, you return the JSON to the client. If the response happens to be 404, you send a message, something went wrong. And finally, in this hypothetical case, if the response is anything else, you return with a status of 500 and a message, server error. When developing RESTful APIs, you can send some resource ID as part of the request URL. For example, You want to create an endpoint that returns book information by International Standard Book Number, or ISBN. But instead of hard coding the ISBN, you want the client to send it as part of the URL. Flask provides dynamic routing for this purpose. Now let's look at a concrete example. Add the variable called ISBN as a dynamic part of the URL. Then pass this variable to the Open Library API. The result is then sent back to the client. Flask also allows you to set the parameter type. The framework uses this information to validate incoming requests. For example, you can create an endpoint of terminals and SFO to get the number of terminals at the San Francisco airport. This route decorator triggers if the user sends a string at the end of the URL. Similarly, in the previous example, you can give ISBN to be a number. Here are some other examples of parameter types in Flask. While string, int, and float are simple parameters, you can also use complex ones like path to indicate a web path or a folder path, or Universal Unique Identifier or UUID to indicate a unique ID like Globally Unique Identifier or GUID. Here is an example of UUID. You can create an endpoint network that has a specific UUID to get information about the network. You can write this code where the route expects a variable UUID of type UUID. The UUID is passed to the method as an argument, and you return a success message if the UUID is found. Otherwise, you return an error code with an appropriate message. In this video, you learned that you can parse the request object to get query parameters, body, and other arguments. You can set status on response objects before sending a response back to the client. And you can use dynamic routes to create RESTful endpoints. Welcome to Error Handling. After watching this video, you will be able to describe different HTTP status that API services can return, explain how error handling works in Flask, and explain how to return errors from your API endpoints. Every HTTP response contains a 3-digit code indicating different error and success status, and the client is responsible for consuming this error code. Valid response code ranges from 100 to 599. The error codes are organized in categories of 100 each. Error codes from 100 to 199 indicate the request has been received and are informational. Error codes from 200 to 299 indicate the request has been received and the requested operation is successful. Error codes in the 300s indicate there is a redirection on the server. Error codes in the range from 400 to 499 show an error in the request. And finally, error codes from 500 to 599 indicate an error on the server side. The APIs you will write in this course will follow this nomenclature. For example, if the client sends a GET request for an unavailable resource, you can send a 404 response back. And you can respond with a status 400 for incorrect requests. Flask server automatically returns a 200 OK status when you return from the @app.route method. 200 is also returned by default when you use the JSONify method to respond to a request. A successful response with the status code of 200 will be sent back when the given code executes. Now, your code can return a different code than the default one. Flask allows you to send the status code in a tuple along with the response. In the code, you send back an HTML response of "My first application in action" with the status code of 200. You can also use the makeResponse method to explicitly set the status code. This code returns the same HTML message and HTTP status code of 200 as the previous code, but here you use the makeResponse method. Let's look at a few more examples of codes you might use in this course. The status of 200 is returned by default. It indicates that the request is successful. 201 tells the client that the server has successfully created the resource. 202 indicates that the request is accepted and is in the process and is common for batch processing operations. The server returns 204 after completing a request successfully. No content is returned. And this status is useful in cases where you don't want the browser to take any action. For example, the user stays on the current page. 400 indicates an invalid request. This status could imply the parameters are missing or improper, or the request is invalid in another way. 401 indicates the credentials are missing or invalid. 403 implies that the client credentials are not sufficient to fulfill the request. And if the server is unable to find the resource, it returns a 404 status. 405 indicates that the requested operation is not supported, and 500 is used when there is an error on the server. So now that you know the different HTTP codes, you as a developer need to return the right code from the service. Let's look at an example. This search response method looks for the database's query parameter Q. The service calls the mock fetch from database method after parsing your query. The code returns the resource to the client if the resource exists. Server returns a code of 200 implicitly and returns 404 if the resource is not found. Now let's call this endpoint using the curl program. Call the route without a query parameter. The curl program returns a message of input parameter missing with a return status of 422. Next, call the route with the correct resource ID. The curl command returns the resource as the body and the status of 200. Finally, call the route with a resource that does not exist. The curl command returns a message of resource not found with a status of 404. Flask provides a way to handle error messages at the application level. Here we see a method that processes the 404 error and returns a message API not found with a status code of 404. Similarly, this snippet creates an error handler for 500 errors and returns a message of something went wrong on the server. In this video, you learned that HTTP response requires a status code to indicate what happens when the request processes. There are multiple classes of HTTP status codes showing success, user error, or server error. Flask implicitly returns a success code of 200 with the response. You can provide status codes explicitly, and Flask provides application-level error handlers.
Welcome to Deploying Web Apps Using Flask. After watching this video, you will be able to describe Flask features, install Flask, create and deploy a Python web app using Flask. Flask is a micro-framework for creating web applications quickly and easily with Python. Flask supports CRUD, which is nothing but create, read, update, and delete requests by making post, put, get, patch, and delete requests. Here is the basic structure of a Flask application. Notice the logo of the Flask package. Let's look at how you can use Flask for CRUD operations. Post requests are used for creating objects or data. For example, you can use post requests to create a user. In most web applications, you will see post being used for creating objects or data. You can use the get request to read data from the server. You can use put and patch requests to update the existing data or objects. You can use delete requests to delete the existing data or objects. Note: most web applications tend to use post for creating, updating, and deleting objects and data, and get for reading. Another video explains the post, put, and get requests in detail. Next, let's look at how to create a web application with Flask. The first step is to install the Flask package using pip, the standard package manager for Python. Like all other packages, you can use the command pip install Flask which will get the most current version of Flask. The Flask package is installed, and you are all set to create the web application. Next, import the Flask package, instantiate Flask class, create a web application, and then run the application. For the purposes of demonstration, let's look at the web application that returns Hello World string as a response to a GET request. Step 1. Install Flask. Step 2. Import the Flask module from the Flask package. To do this, import the Flask class from the Flask module. Step 3. Create an object of the Flask class as a web application with the name My First Web Application and store it as app. For example, app equal to Flask with My First Application. Most applications use the reference name app for clarity purposes. However, app is just a reference name and you can use any other name. Step 4. Define the root and the method that will be invoked when this root is accessed. For example, enter at myapp.root open round bracket single quote slash single quote close round bracket. Notice in this example, neither GET nor POST have been specified. When you do not specify a request, by default, GET is requested. Therefore, in the example, the endpoint will now be able to serve GET requests to the root. Step 5. Hello is the method, written as def hello open round bracket close round bracket colon. The Hello World method will be invoked when the system accesses the API endpoint that was defined in the previous step. The code to do this is app.run open round bracket debug. It takes no parameters and returns the string Hello World. In the code, this is written as return single quote Hello World exclamation sign quote. Step 6. Add a condition that web application should run only if name attribute is set to main. By default, name is set to main unless it is explicitly changed. You can save and run this like any other Python application. Tap myapp.run open round bracket debug equals true with capital T close round bracket. To start the server in a development environment, you need to save the code in a Python file and run it like any other Python application. When the web application server starts, it gives you the IP address and the port the application can be accessed from. To check the endpoints, you can open the browser and connect to this endpoint you see in the server output 127.0.0.1 at port 5000 and see the string Hello World being returned from the web server application. Templates are nothing but pre-created HTML pages that are served from the web application. They can be both static and dynamic. By default, the Flask application looks for the templates in a directory called Templates under the root directory. If the templates need to use images, styling sheets, or JavaScript files, which are stored in a folder named static in the root directory, the static pages are rendered as is. The dynamic pages usually have information that is filled in dynamically for each request. These pages are often based on the values passed as arguments. The arguments can either be passed through the URL or be passed as request parameters. Let's look at a sample Flask application. You start with importing Flask to create web application, request to handle the incoming request, and render_template for rendering static and dynamic HTML pages. Type from Flask F lowercase, import Flask with capital F, comma, render_template, comma, request. Next, instantiate Flask and set the static folder. For example, myapp equals Flask open round bracket double quote my with capital M. First, application with capital A. The default folder name is static, but you can have the static contents in a directory with a different name as long as you set it explicitly. Notice there are 3 endpoints in this web application. The first is /sample. This will render a static HTML page. The image in this HTML is sourced from the static directory. The code to accomplish this is myapp.root open round bracket single quote / sample single quote close round bracket. In the second line, type def get sample HTML. Note there is no space between get sample HTML. In the third line, type return render template sample.html. The next one is /user/username, where the username that you see within angle brackets is the parameter. The code is written as @myapp.root. Users specify the username methods equals get. If you see the method has been explicitly set to get, this is just to show how you can set the type of request. If nothing is specified, it is considered a GET request. The page is rendered with the parameter we passed in the URL. The last one is /user/username, where the username is passed as a request parameter. The page is rendered with the parameter which was passed as a request. In this video, you learned that Flask is a micro-framework for creating web applications and supports CRUD. Install the Flask package using pip. To create a web application using Flask, import Flask, instantiate Flask, run the app. You can render both static and dynamic templates with Flask.